Hello everyone. So this is the second video on linear algebra. So in the last class we studied up to vector spaces and some examples on the vector spaces. Now we study what are subspaces and we will encounter some examples. By the end of this class I will give you some examples to work out. Kindly work out them. If you have any doubts, let me know in that while solving those questions. First thing is, what is in the subspace of a vector space? So to be very precise, if V is an vector space over the field F, then consider any subset W. W is a subset of V and it behaves like a vector space over the field F. What all the properties that are true for this vector space, the same will be true for this. That means it will become an algebraic structure. This W will become an algebraic structure as similar to V. In other words, we can state it as a subset W of V is called a subspace over the field F if W itself a vector space over the field. Then we say that W is a subspace of the vector space B. Okay. Coming to this, how many subspaces are there? How many trivial and non-trivial? For that, given any vector space, and zero space, it's called, are always subspaces of the vector space. These two vector spaces are called trivial subspaces. This idea is clear? Similar to the groups we have here, subspaces. One is the zero space, another one is the whole of the space. This idea is clear? Zero space we denote it by some 0 and V will denote it by zero space. Okay. Then remaining, if W is a subspace which is not trivial, trivial means it is not equals to V as well as it is not equals to the zero space, then it is called non-trivial or else proper subspaces. These are improper. The idea is clear? We will discuss how many subspaces will be there for a given space. That can be answered if you are dealing with finite dimension vector spaces. Hopefully this idea is clear to you. And the second thing is how to, when we say this will be the subspace. See, for that there are two verifications are there. One is called two-step verification. First I will try to explain this. Whenever if W1 and W2 are in W, W1 plus W2 must be in W. Then for any alpha belongs to the field F and W belongs to the subspace W, then alpha into W must be in W. This must work. Is the idea is clear? If these two conditions are satisfied, we say that it's a subspace. Or else, see, this, that's why it's called two-step. We check with these two steps. ಎರಡು ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಚೆಕ್ ಮಾಡಿದ್ರೆ ಟೂ ಸ್ಟೆಪ್ ವೆರಿಫಿಕೇಶನ್ ಅಂತ ಕರಿತೀವಿ. ಒಂದೇ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಚೆಕ್ ಮಾಡಿದ್ರೆ ಇಫ್ ವಿ ಚೆಕ್ ವಿತ್ ಒನ್ ಸ್ಟೆಪ್, ಹೇಗೆ, ಹೌ ಟು ಡೂ ಇಟ್? ಸಿ, ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ದಿಸ್ ಯು ಸೇ I will scale this, then I will add, I will scale these parameter and I will add. That is, if alpha and beta are from the field F, and W1 and W2 are from the subset W. If alpha W1 plus beta W2 is in the subspace, then we say that it's an field. Sorry, it's in subspace. See, some students will confuse with this. This must be from V and this also from V. No, it's from the. Although it is from V because W is a subset of V. That is true. But however, you must be very particular about it. You must take an element from W, and it must be additively closed with respect to W, and it must be closed with respect to scalar multiplication. Then we say that it's a subspace, and we will try to use any one of this to think about, to test whether the given subset is a subspace of the given vector space. I have some examples here, so we will just try to solve them. See, V is a vector space of all functions, right, such a way that F is a function from, it's a real valued function R to R. Which of the following functions are subspaces of V? First thing is, you have the function such a way that f of x square is equals to f of x whole square. How to think about this? See, only idea is this. If I want to show W is a subspace, take any two elements from this W, right? You say V1, V2 belongs to W, and alpha, beta are scalars. Alpha into V1 plus beta into V2 must be in W. Howda? So I can check with that. See, this is my W now. I have the subset. I need to show. I don't know whether it is a subspace or not. I am checking now. W is a subset such that it contains the function of this nature. F of x square equals to f of x whole square. Just say alpha, beta are from the field F. Then let me say F1, F2 belongs to W1 antindro idana. I will say W1. So how does F1 of x square will look like now? It is F1 of x whole square. How does F2 of x square look like? It is F2 of x whole square. Now whether alpha into F1 plus beta into F2 belongs to that W1 is the question. How to check? Just say x square. So it is alpha F1 of x square plus beta F2 of x square. It is alpha F1 of x whole square, because F1 of x whole square is F1 of x whole square, plus beta F2 of x square. F2 of x square is F2 of x whole square. Alle kottidane adana. But this is not equals to, what is alpha F1 plus beta F2 of x whole square? This is equals to alpha F1 of x plus beta F2 of x whole square. Alpha square F1 of a plus b whole square formula. B square F2 of x whole square plus alpha beta F1 F2 of x plus alpha beta F2 F1 of x. So this is not, both are not equal. Am I right? Call this as 1 and call this as 2. Both are not equal. That means it is not a subspace. How about the second one? Similar to that, you say F1, F2 belongs to W2. Idana W2 antini. Ek barkobodu idana. Just check alpha F1 plus beta F2 of 0. It is alpha F1 of 0 plus beta F2 of 0. What is F1 of 0? F1 of 0 is, if F1 is in W2, F1 of 0 equals to F1 of 1. Howda? Artha agbekadu. What is F2 of 0? F2 of 0 is F2 of 1. So it is alpha F1 plus beta F2 of 1. See, alpha, I started with 0 and I am getting 1, the same thing I wanted. So it's a subspace. This is not a subspace, second one is a subspace. How about the third one? W3. All f such that f of 3 equals to 1 plus f of minus 5. Just say f1, f2 belongs to W3. It implies f1 of 3 equals to 1 plus f1 of minus 5. f2 of 3 equals to 1 plus f2 of minus 5. Now the thing is alpha f1 plus beta f2 of 3. It is equals to alpha f1 of 3 plus beta f2 of 3. What is alpha into f1 of 3? f1 of 3 is alpha into 1 plus f1 of 5 plus beta into 1 plus f2 of minus 5. So alpha plus beta plus alpha f1 of minus 5 plus beta f2 of minus 5. See, I wanted to get if alpha beta is 1, then it will be the subspace, but there is no given condition there. I cannot, it must be true for any scalars. Is the idea is clear? ಇದು 1 ಪ್ಲಸ್ ಸಮಥಿಂಗ್ ಆಗಬೇಕು, ಹೌದಾ? ಅದೇ ತಾನು ಹೇಳ್ತಾ ಇರೋದು ಎಫ್ ಆಫ್ ಮೈನಸ್ 5. ಆದರೆ ನನಗೇನು ಸಿಗ್ತಾ ಇದೆ ಇಲ್ಲಿ? ಐ ಆಮ್ ಗೆಟಿಂಗ್ ಆಲ್ಫಾ ಪ್ಲಸ್ ಬೀಟಾ. ದಿಸ್ ಈಸ್ ನಾಟ್ ಈಕ್ವಲ್ಸ್ ಟು 1, ರೈಟ್? I cannot claim this is equals to 1. It may be any scalar. Getting my point? So it is not a subspace. If I get 1 plus alpha something likewise of f of minus 5, then I could have been said, yeah, it is true. Right? I am getting this as alpha plus beta plus alpha f1 plus beta f2 of minus 5. There is no assurance that this is equals to 1. If this is equals to 1, I can claim that it's a subspace. So this is not a subspace. How about the fourth one? Nodi, W4. I am checking for the fourth one. Say f1, f2 belongs to W4. So f1 of minus 1 is 0, f2 of minus 1 is 0. What is alpha f1 plus beta f2 of minus 1? It is alpha f1 of minus 1 plus beta f2 of minus 1. So now what you will have? For this you will have, this is 0, this is 0. So alpha into 0 is 0, beta into 0 is 0. 0 plus 0 is 0. So alpha f1 plus beta f2 of minus 1 is 0. So it contains the function such that f of minus 1 equals to 0. Here some function into minus 1 is 0 means this is in W4. So W4 is a subspace. How about W5? Set of all continuous function. So if I add any two continuous function, it will be continuous, or if I scale a continuous function, it will be a continuous function. So this is a subspace. This idea is clear. Next I have some examples like it's an Rn, okay, and I want to check whether it's a subspace over R. This idea is clear. Already we noticed Fn is a vector space over F, but however here there is some restriction is given. First thing is you should have all A such that this, I need to check whether A is a subspace or not. You see, it has entries A equals to A1, A2, etc. up to An, such that A1 is less than or equals to 0. And a scalar you can take from real numbers. This idea must be clear. It must contain n tuples irbeku, and the scaling quantity ಯಾವ್ದ್ರಿಂದ ತಗೋಬೇಕು, ನಾವು ರಿಯಲ್ ನಂಬರಿಂದ ತಗೋಬೇಕು. ಆ ವೆಕ್ಟರ್ನ ಜಾಸ್ತಿ ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡ್ತಿರೋ, ಕಾಂಟ್ರಾಕ್ಟ್ ಮಾಡ್ತಿರೋ, ದಟ್ ಡಿಪೆಂಡ್ಸ್ ಅಪಾನ್ ಯುವರ್ ಸ್ಕೇಲಾರ್. Getting my point? You can scale that vector. Either you will magnify or else you are going to shrunken that vector. It is measured by this R. However, look to this set of all A such that A1 is less than 0. ಅವನು ಹೇಳ್ತಾನೆ, you take the first entry less than or equals to 0. If I take the first entry less than or equals to 0, let me assume I took minus 1. Okay, here I took A2 ಏನಾದರೂ ಇರಲಿ ಅದು, I am least bothered. So if I multiply by -1, what will happen for this? This will become +1. ಹೌದಾ? This will become minus, and I am just bothering about this. What will happen to the first entry? It will be positive. But I want all such entries to be less than or equals to 0. Here I am getting a positive value. That means once I have the first entry to be restriction is given, either it is less than or equals to 0, by choose a negative scalar, it will become positive. If he says no, it should be greater than or equals to 0, choose again a negative scalar, it will become positive, or else negative. You choose any negative scalar here, some minus alpha times this will be negative, where alpha is positive here. So minus alpha is always negative. Artha agata? So if he gives a1 is less than or equals to 0, then you cannot say it's a subspace, because a1, a2, an, this is less than 0. Multiply by a scalar alpha, where alpha is saying this must be less than or equals to 0. You multiply alpha, where consider alpha to be less than 0. What will happen for this? The first term will become positive. The second term, I don't know, whatever it is, let it be b2, bn. But if it is positive, can it be in that subspace? He is saying every entry should be negative. Here I am getting a positive, so it cannot be. So this cannot be the subspace. All a such that a3 is an integer. ನೋಡ್ರಿ ಮೂರನೇ ಎಂಟ್ರಿ ಇಂಟೀಜರ್ ಬೇಕಂತಾನೆ, ಹೌದಾ? Multiply by some real number which is not integer. Multiply by √2. So what it will become? It cannot be integer. ಅರ್ಥ ಆಗುತ್ತಾ? So it cannot. For example, I have 3 here. Multiply by √2. 3√2 is never an integer. So the integer ಆಗಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ. That means if you scale or else if you add, still you want to get the same condition. All a such that a2 plus 4a3 equals to 0. ಇದಾಗುತ್ತೆ. You can check. You say a equals to a1, a2, etc. up to an, b equals to b1, b2, etc. up to bn. You take this condition. Okay, you will get a1 plus 4a3 equals to 0 here. Here b2 plus 4a3 equals to 0. Then add it, you will get the same. Okay, this will be the subspace. See, all a such that a1 plus a2 plus etc. an equals to k. See, this cannot be the subspace. You should ask me why for this. See, a given constant. Given constant means, let me assume I will take k equals to 1. You can give any constant, so I will assume k equals to 1. So a1 plus a2 etc. an equals to k means the sum should be equals to 1. That means at least any one of the entry must be non-zero here. This idea is clear. Can I get 0 element here? If I want to say it's a subspace, for this D I am saying this. If I want to say D is a subspace, the sum of all those entries must be 0, whether it is possible. Sir, why you are bothered about 0? The reason is, I am bothering about 0 because once I say W is a subspace, it must contain 0 element. How does 0 element of this will look like? 0, 0, 0, n times. If I sum it, it will be a1, this is a1, this is a2, this is an. a1 plus a2, an must be equals to 0. ಹೌದಾ? But can I get, if I assume k equals to 1, will it be 0? It's not possible. So if he says given constant, it's not possible. If it is equals, it depends upon the constant. If he gives it is equals to 0, you can check. It will become the subspace. If not, it won't. Again, E is given all A such that A1 plus 3A2 equals to A3. This will form the subspace. You can check that. All F such that A2 equals to A1 square. This won't form. Similar to this, as we observed the first example. You will get something likewise. This won't form. all A such that A1 into A2 equals to 0. See, G is this. Let me assume 1 0 0 0 1 0. So A1 A2 A1 into A2 is 0. Here B1 B2 B1 into B2 is 0. That's what he is telling. Hoda? So add them. What is A plus B? Component wise add ಮಾಡಬೇಕು. 1 1 0. Multiply now these entries. So 1 into 1, it is not equals to 0. That means this one form the subspace. All A such that A2 is rational. It's not possible because a rational is there. You multiply by a real number. Let me say you multiply it by root 2. So root 2 into some rational, root 2 into A by B. Then A2 under A1, A2, etc. A2 let it be A by B. Multiply by a scalar root 2. Whether it will be a rational, it does not belongs to Q. So this one form the subspace. Idea is clear? This idea is clear. Okay. I had given you some examples here. Before I go into that, I will discuss one more thing. See, let me assume A into X equals to B. Okay. A is a matrix. X is unknowns. B is again a matrix. We already encountered this kind of problems. For example, if there are m linear equations like a11 x1 plus a12 x2 plus etc plus a1n xn equals to 0, a21 x1 a22 x2 a2n xn equals to 0, am1 x1 plus am2 x2 plus amn xn equals to 0. So how many equations are there? 1, 2, 3 etc up to m equations. How many unknowns are there? 1, 2, n unknowns. This you can put it in the matrix. A into x equals to B. B is the coefficient matrix, that is 0 matrix here because the coefficients are 0. X stands for this x1, x2, xn. This stands for a11, a12, a1n, then again a21, a22, a2n, etc. am1, am2, amn. This is equals to. So that's what we were doing. We will multiply it and we will just think about, there are many methods to think about this. How the Cramer's rule is there for finding the inverse. If A is invertible, you will find A inverse and you will say x equals to A inverse into B. Likewise, there are methods are there to solve this, to solve the systems of linear equations. However, one thing you need to observe here, the set of solutions of the homogeneous systems of linear equation. What is homogeneous? B must be equals to 0. That is called homogeneous. The set of all solutions of the homogeneous systems of linear equations. This is an homogeneous system and its linear equations are there. It will form the subspace. Subspace of the given vector space. Whereas vector space is nothing but solution space. But if it is non-homogeneous, it won't form the subspace. If B is non-zero, then it won't form the subspace. Clear? Why it won't form the subspace? For example, A into x1 equal, let me assume A into x equals to 0. Whether this is homogeneous or non-homogeneous, since it is 0, it is homogeneous. let x1 and x2 be two solutions. So a x1 will be equals to 0 if x1 is the solution. If x2 is the solution, a x2 equals to 0. What will happen to a x1 plus a x2? It will be a x1 plus x2. This is also the solution. Getting my point? If x1 is the solution and x2 is the solution, a into x1 plus, or else you can think about b into x2 also. Alpha, alpha ax1 plus beta ax2. Still this is equals to 0. Getting my point? So again, what else the observation here is, if you have the homogeneous system, it will form the solution set will form the subspace. If you have a non-homogeneous, then it won't form the system. Why? Let me assume x1 is the solution and x2 is the solution. A into x1 equals to b, b into x2 equals to b. So what will happen to a x1 plus b x1? It's equals to 2b, not equal to b. That means x1, if I add those two terms, it won't form the solution, because I need to get b in the right hand side, but here I am getting 2b. Getting my point? So the set of all solution, the solution set of the homogeneous linear system will form the solution. The idea is clear? So next question is R square is a subspace of R cube? No. Why? Because R square is plane, R cube is the 3D, what else we observe. R square, can I accommodate R square in R cube? How does R cube will look like? It's 3 tuples. How does this will look like? Can I think about this using this? Not possible, because it is only 2 possible, 2 fellows are here. Here there are 3 fellows. So I cannot claim that this can be accommodated here, because I cannot compare these two. Subset agutto ilvo antane compare madakagala. If I want to compare, I must have one entry here, but that is not possible. Since there is no question of thinking about the subset, there is no question of thinking about the subspace. But some will write, yes, it will form the subspace. No, this is the idea. It won't form the subset, so there is no question of thinking about subspaces. Is the idea is clear? Next thing is whether the what will happen to this solution? 2y double dash plus 9y dash plus 2y equals to 0. So consider this differential equation, and what will happen to the solution set of this? See, since it is homogeneous, this is an homogeneous system, right hand side is 0. This idea is clear. So if y1 is the solution and y2 is the solution, we know y1 plus y2, that will also form the solution, or else alpha y1 plus beta y2 will form the solution. So this will form the subspace. But if I assume in the right hand side equals to q of x, where q of x is non-zero for any differential system, so that won't form the vector space, because once you have the non-homogeneous, the superposition does not hold. That means if y1 is the solution and y2 is the solution, you cannot claim y1 plus y2 will form the solution. This idea is clear? Just kindly think about this, and I had given you some examples here to work out. Kindly work it out. As I said, if you have any doubts, let me know. I will drop this in the WhatsApp group so that you can solve this. Okay. You can just pause the video and you can try to solve these questions. I had already given to show V is not a vector space. Why you need to justify, that's all. So this is on subspaces. And this is on the functions. Thank you.